Okay, so in this series of videos I'm going to be going through the entire GCSE Maths paper 2, which is 2018 and it's November, and this is the foundation tier. So I'm going to go through this entire paper. I've already released the paper 1 for foundation November 2018, so that is already in a playlist on my channel, but this is paper 2, and then after this I'll do paper 3 and then move on to the higher tier and so on. So this is just a quick introduction saying this is a calculator paper, and yeah, it's GCSE Maths Foundation Tier November 2018 paper 2. So for the first question on this paper, we are told we've got a rectangle as shown here, and we just simply need to work out the perimeter. So the perimeter is the length of every single side on the rectangle added together, so we can label the other sides. These two are the same, so this is 7, and then these two are also the same, so this is a 5, so it comes out as 5 plus 5 plus 7 plus 7, and this is equal to 24 centimeters, so the answer is 24. Okay, so for question 2, we need to circle the number that is greater than negative 0.9. So if something is greater than negative 0.9, if we quickly just draw a number line with this being 1, this 0, and this negative 1, 0.9 falls at about this point here, so we can say this is negative 0.9, and a number that is greater than this must be going this way, so anything that is less negative or more positive than negative 0.9 is greater. So we can see this number here, the first one, negative 0.901, that is more negative, so it's not that one. This one, again, more negative, and minus 9/10 is the exact same number, so it's the same, but whereas 0.89, negative 0.89, sorry, this number is more positive and is therefore greater than negative 0.9, as it would be around this point here. Question 3, we need to simplify this algebraic expression, 8x minus 3 plus 6x. So we collect like terms, so we add all the x's together, so we've got 8x plus 6x, which gives us 14, wrong pen, 14x, and then we're left with the takeaway 3, and that is the final option there. So question 4 is a bit of a weird one. It says, what is the angle of turn clockwise from southwest to east? So if we label on the other points on our compass, do this really quick, so south, and then it's we is how I remember it, so W-E, reading from left to right, so W and then E, and we're going from southwest, so that is this point here, so we can say this is southwest, and the clockwise turn, so we are going this way round, so from southwest to east. So if we move here all the way around here, what we can see is that this is 180 degrees, and then as this is a right angle 90 degrees, this must mean that this part here is 45 degrees, so the answer is 180 plus 45, which is equal to 225 degrees, and the third choice. Question 5, we are told that Lucy works 37 hours per week, her weekly wage is £303.40, and she receives a pay increase of 25 pence per hour, and we need to work out her new weekly wage. So to work out her hourly rate currently before the increase, what we do is we take her weekly wage, currently £303.40, and we're going to divide it by the number of hours she works in a week, which is 37, and this is going to work out the amount she earns per hour. So when we type this into our calculator, £303.40 divided by 37, we end up with £8.20, so she's currently on £8.20 an hour, and she's then earning an extra 25p, so we do our £8.20 or 8.2 plus 25, but I nearly made that mistake then, it's not actually 25, as it's 25p, it's 0.25, and this is equal to 8.45, and then we do our new hourly rate, 8.45, £8.45, multiplied by the hours per week, which is 37, and when we do this, we end up with £312.65p. So the final answer is £312.65p. So for question 6, part A, we are told that we need to complete a bank statement. Okay, so where it says debit means we take that amount away, and credit means we add that amount. So what we do first of all is, for this answer here, we do 1140.79, take away 256, and when we do that, just type it into my calculator, we end up with £884, so 884, and then 79p remaining. Okay, we do the same again. This time we take away £87.31. So from our previous answer, we take away £87.31, and this leaves us with £797.48p. Okay, so for the final column, for salary, what we do with salary, as it's credit means we add, and of course from before, debit means we subtract. So we then add to our £797.48, we add £2,069.75, and this leaves us with £2,867.23p. So for part B, we need to write down the meaning of debit as used in the bank statement from part A. So like I've already said, debit basically means an amount that we take away. So it's an amount of money that's owed. So a definition you could write down is something like an amount of money taken out of an account, and that'll be enough for the 1 mark for that question. Okay, so for question 7, we are shown a line AB on the grid, which is here, and we are given the points of A and B being 0, 2 and 6, 5 respectively. We are then told that we need to work out the coordinates of the midpoint on the line AB. So to make out the midpoint, we need to calculate the change in X and the change in Y coordinates first of all. So the change in Y, we start from 2, the point A, and we go all the way up to 5. So the change in the Y coordinates, what we do is we take the larger number, 5, take away the smaller number, 2, and divide this all by 2. And when we do that, we are left with 3 over 2, which is equal to 1.5. We then do the same, but for the X coordinates. So we start at 0, and we end up at 6. So we do big, take away small, all over 2, and this equals 3. So with these two values, what we do is we plus 1.5 to Y, so this happens to the Y, and we plus 3 to the X. Now we start with our smaller coordinate, so the one that's at the bottom of the line, which is 0, 2, and we add the values that we've just worked out to 0, 2. So we end up with 0 plus 3, and then we've got 2 plus 1.5, and this comes out as 3, 3.5, and if we plot this on our graph, we go to 3, and then 3.5, and when we do that, we get roughly this point here, which is just from looking at it in the middle of the line. So our final answer is 3.5. So for part B, with question 7, we are told C is another point on the line AB. C is closer to B than A, and the coordinates of C are whole numbers. Work out the coordinates of C. So the key points are C, the coordinates are whole numbers, and it's closer to B than A. Okay, so go back to our original line. Just rub these points out. Okay, so actually we shouldn't have rubbed out the midpoint, but it was here anyway. So if the coordinates of C is closer to B than A, and they are whole numbers, this means it's going to be in this part of the line somewhere. And if they are both whole numbers, there's only one place it can be, which is this point here, and this is 4, 4, so the answer is simply 4, 4. So for part C of question 7, we are told that on the grid from part A, which is up here, we need to draw a line from the point 0, 0, the origin, that is parallel to AB and is 2/3 as long as AB. Okay, so AB is of course this line here as well. So it starts at 0, 0, we can mark that on, and it's 2/3 of the length of AB. Okay, so if AB runs up until the point 6 on the x-axis, ours is going to be 2/3 of that length, so ours is going to go up to 4. This is also true because the lines are parallel as well. That's really important. So in terms of the y-axis, our original line AB runs from 2 all the way up to 5, so it's got a length of 3 points. So our new line, is going to be 2/3 of this length, so it's going to be 2 squares tall. So we go up 2 squares on the y-axis from where our line's starting, so we go up to the point 2, and then all we have to do is meet our points 4 and 2 here, and this is going to be our line going from the origin up to the point 4, 2, and that is 2/3 of the length of AB, and it is also parallel. Okay, question 8. Lena is at the gym. She will use each of these pieces of equipment once, and we've got row machine, treadmill, stepper and bike. Lena will use the row machine first, okay, and then we need to list all the possible orders in which she could use the 4 pieces of equipment. So they've already denoted a letter for each of these machines, so we don't have to do that. So she uses the row machine first, so that's always going to be the case. So she could then do, she could then do stepper, treadmill, bike, so S, T, B. I'll write a load of R's down. She could then do stepper, bike, treadmill. She could then do treadmill, stepper, bike, treadmill, bike, stepper, and we need one more R, I believe. And she could then do, let's see, which one haven't we done first? B, so B, and then we'll do S, and then T, and then B, T, S. And they are all the combinations. So the way I've done it is, obviously R's got to come at the start, and then we start with one letter, S, being in the first position of the 3 remaining, and then we put the other 2 letters down in any order. We then reverse these 2 letters, and they are all the combinations for RS being at the start. We then move on to a new letter in position 2, which is T. So we keep RT the same, and we put the other 2 letters down, doesn't matter which order. We then reverse it, and then we move on to our third combination for the first 2 positions, and do the same thing again. And they are all the possibilities for the orders she can use equipment in the gym. So I actually thought that was the end of the question then, but looking back over my answer, I've realised that we need to work out what time she finishes on the last piece of equipment, and she starts at 1:50. So we go from 1:50, so 1:50 PM, I believe it was, yeah, PM, and then we plus our 2 hours 45 minutes, and this takes us to plus 2 hours, we get 3:50 PM, plus 10 minutes, we get to 4 PM, and then we've got 35 minutes remaining, so we get to 4:35 PM. Okay, so for part B, we are given a table which shows how long Lena spends on each piece of equipment, as shown here. Lena starts on the row machine at 1:50. She has a break of 4 minutes between pieces of equipment, and we need to know what time does she finish on her last piece of equipment. So, okay, so in total, there's 4 pieces of equipment, so there's going to be a break here, a break here, and a break here, so that's 3 breaks. And each break is 4 minutes, so we do 3 times 4 equals 12 minutes break in total, and then all we need to do is add up all of these durations for each piece of equipment. So we've got, we'll keep it in hours as well, so we've got 1 hour 30 mins plus 15 minutes plus 13 minutes plus 30 minutes. Not 30, it should be 35. 35 minutes, okay. So when we add all of these up, we get from these two, we get 1 hour 45, we then get 1 hour 58, and we then get 2 hours and 33. So this is equal to 2 hours 33 minutes, but we've then got to add our 12-minute break as well. So 2 hours 33 minutes plus our 12-minute break is equal to 2 hours and 45 minutes. Okay, so for question 9, we are given a table and it shows the number of messages that Sam received each day for 5 days, and it's in terms of emails and in terms of text. We are then given a diagram here, which is a bar chart showing the data from the table. And the first day for Monday has already been completed, so as we can see, we've got a line at 12 and then another one at 17. So as you can see, we've got 12 emails and then 17 take away 12 leaves us with the 5 texts. And for part A of the question, we need to complete the chart. So what I'm going to do to make this a bit clearer for ourselves is make this blue, and then I'll make this bit red. Okay, so let's do the blue first. So for Tuesday, he received 8 emails, so we go up to 8 on Tuesday. Okay, and then we'll just shade that in. And then on Wednesday he received 10, so we go up to 10. And again, we'll just quickly shade this in. Thursday he received 6, and then Friday was 12. Okay, so Thursday we've got 6, and then Friday it was 12. So that's the number of emails completed. So now all we have to do is complete the number of texts. So on Tuesday he received 6, and then Wednesday was 3. So we go up 6 places from where we left off. So 8 plus 6 is 14, so we go up to 14. And again, we'll just shade this in really quickly. And then the next day I think was 3. Yep, so 3. So we go up 3 places. So we go to 13. So try get right in the middle of that square there. In the exam they'll give leniency, maybe it's usually about plus or minus 1 square or half square, so just be as accurate as you can. Thursday it was 6, and then Friday it was 4, so we go up another 6, taking us to 12. Okay, and then we go up 4 from here, so we go all the way up to 16. And for 2 marks, it's quite a lot of time spent on this question, but it is a very easy 2 marks, and that is the completed chart for question 9A. So for question 9B, we are asked, in total, what fraction of the messages received were emails, and we need to give our answer in its simplest form. So if we go back to the original table, we need to count up the number of emails, and then we also need to count up the number of texts. Okay. So for emails, we've got 12 plus 8 is 20, plus 10 is 30, plus 6 is 36, plus 12 is 48. So in total, we have got 48 emails. And then we'll do the same for the number of texts. So 5 plus 6, 11, plus 3, 14, plus 6, 20, plus 4 is 24. So we have got 24 number of texts. So the total number of messages is 48 plus 24 emails plus text, and this is equal to, we get 72. So then we need to work out the fraction of messages that were emails. So the number of emails that we received were 48. So what we do is we take our 48 and we then divide it by 72, and we just need to simplify this fraction. So what can we divide by? We'll just divide by 2 initially, so dividing by 2, top and bottom, we are left with 24 over 36, and then we'll divide by 2 again, so 2 top and bottom, and this leaves us with 12 over 18, and then I can see that we can just divide by 3 now. So if we then take our 12 over 18, and if we divide top and bottom by 3, we are left with 4 over 6, and then we can divide finally by 2 again. And I know I've gone a very long way to solving this fraction, but if you're unsure of what the highest common factor is in the exam, you can just do this way, starting with 2 and so on, and you will still get the same answer. So divide by 2 over 2 again, we are left with 2 over 3, so we can say that 2/3 of the messages received were emails. So for question 10, we are told that each side of a square is made 3 times as long, and we need to say what happens to the perimeter. So let's say we've just got a regular square with lengths x. So we can therefore say that the perimeter P is equal to 4x, just adding all the lengths together. So let's see what happens when we make the sides 3 times as long. So we'll make a bigger square, and then we'll make these all 3x. And then the perimeter for this is 3 plus 3 plus 3 plus 3x, so that is equal to 12x. And we can see that our 12x from the new square divided by our 4x from the old square is equal to 3, so it's 3 times the length in terms of perimeter. Okay, so for question 11, we are given a list of ingredients needed to make 6 pancakes. That's the key piece of information, 6 pancakes, and they're shown in this table here. For 11a, we need to complete the list of ingredients needed to make 9 pancakes. So the first thing to do is to work out how much of each ingredient do we need for 1 pancake, and then we can scale that up to 9, okay? So if this data here is for 6 pancakes, to find out what 1 pancake is, we are going to divide each of these values by 6. So this gives us 20, divided by 6, this gives us 1/3, and dividing by 6, just grab my calculator, so 210 divided by 6 is equal to 35. Okay, so now that we've got the amount for 1 pancake here, we then multiply this by 9 to get the amount for 9 pancakes. So for the first column, which is for flour, we do 20 multiplied by 9, which is equal to 180. The second column, eggs, we do 1/3 times by 9, which is equal to 3. So we need 3 eggs. And then for the final column, milk, we do 35 multiplied by 9, which is equal to 315. And it'll be millilitres as well, so it's always good to put the units. So we'll put grams, then we'll just put eggs, then we'll put millilitres as well. So for question 11b, we are told that we need to convert 210 millilitres to fluid ounces, and we are given the conversion rate here. 1 fluid ounce is equal to 28.4 millilitres, and we need to give the answer to 1 decimal place as well. So what we need to do is take our 210 millilitres and then divide by the amount of millilitres in 1 fluid ounce, so divided by 28.4. And when we do this, this comes out as 7.39, and then there's some more decimal places at the end of this, but as we only need it to 1 decimal place, we simply round up the 9. So we round up the 9, and this is equal to 7.4 to 1 dp. So therefore our answer is 7.4 fluid ounces. For question 12, we are told to reflect shape A in the x-axis. So shape A is this triangle here, and the x-axis is of course this here. So all we've got to imagine is we've got a mirror running down this axis, and we are just reflecting what we'd see in the mirror into this area here. So the way I do it is I go to the first point on the triangle here, and I see how far away it is from the x-axis. So it's 1 square away. So all we have to do then is go 1 more square away to here, and that is where the new point is going to be. We then do the same for this point. It's 1 away, so we go 1 away again. So that is our new point. And for the final point on our triangle, it's 1, 2, 3, 4 squares away. So we go 4 squares away in the bottom left quadrant, away from the x-axis. So we go 1, 2, 3, 4, and that is the point of our final piece in the triangle. So now all we have to do is join our triangle up, like so. And that is our triangle reflected in the x-axis. So question 13 is worth 6 marks, which is a huge amount for a foundation paper. So this is a really important question to understand and get marks on, because it could be the difference between a grade being 6 marks. That's a large percentage of the exam. So what we are told is a charity sends an appeal letter to 3,000 people. So I'm just going to highlight the key piece of information as we go along. The letter asks for a donation of money, okay, and here's some information about the last letter appeal that the charity sent out. So we are told that half of all people who were sent the letter made a donation, so a half, and the average donation was £8.60, so we'll circle that as well. And then we are told a third of the people who made a donation filled in a tax form, and the government adds 25% to the donations of these people. So a third gets an extra 25%. So the actual question is, using this information, work out the amount the charity can expect to receive from this appeal. So the amount of people is 3,000 up here, and a half of these people make a donation. Okay, so that means 1,500 people make a donation, so donate. We are then told that a third of the people who make a donation fill in the tax form. So a third of 1,500 is equal to 500 people. So 500 people, and we can say fill in tax form, which leaves us with 1,500 people. Take away the 500 who filled in the tax form, leaves us with 1,000 people who just made a regular donation. So these made regular, so I'll just put reg donation. Okay, so now we just need to work out how much these 500 people pay with donation plus the government's addition, and then how much these 1,000 people pay, and then add them together to work out the total amount they can expect to receive from this appeal. Okay, so for the 500 people who fill in the tax form, we can take the average donation of £8.60. So we've got 8.6 for £8.60, and then it's multiplied by 500 for the 500 people. But then we need to remember the government adds 25% to the donation. So what we can do is this amount, and then to find an extra 25%, we multiply by 1.25, which gives us an extra 25%. And when we do this, I'll just put it in my calculator. So 8.6 times 500, and then multiplied by 1.25, that is equal to £5,375. So we'll put a pound sign there. So that is this part done up here. So we'll now move on to the other 1,000 people who donated. So we've got £8.60 times by 1,000, and this gives us the amount of money that they donated. So if we times by 1,000, we are going to get £8,600. And again, it's always good to double check these things in the calculator in the exam, so I'm going to do that now just to be absolutely certain. So yeah, we get £8,600, and then the final step to do is to add these two values together. So we get 5,375 plus 8,600, and again, using our calculator, when we add these two values together, we get 13,000, so remember our pound sign, £13,975. So we'll just put that in the answer line. So £13,975. And that is the total amount that the charity can expect to receive from this appeal. So for part B of question 13, we are told that the average donation from the people who filled in the tax form was more than £8.60, which was the original amount. So we've got to say, how does this affect our answer in part A? So in part A we worked out this amount of money here. So we are told that the people who fill in the tax form, the government adds 25%. So if the amount that they donate on average is greater than £8.60 and they're getting an additional 25% to their donation from the government, we can say that obviously this is going to be higher, as the government, so the Gov adds 25% of the donation to the final amount. And that will be enough for the 1 mark in the exam. Question 14, we are told that Lee wants to draw the graph of y equals x for the x values of -5 to 5, and we are shown the graph that he's drawn here, and we need to make 2 different criticisms of his graph. So first of all, we can see that he's gone to the point 4 and -4 on the x. So the first thing that we can say, as he's meant to go from -5 to 5, is his graph ranges from, and then we can say -4 to +4 in the x axis instead of -5 to 5. So that'd be the first thing that we can say. The second thing is obviously the graph is just wrong. This line should not be here. It should carry on down here like so for y equals x. So we can say the top left quadrant is wrong. The coordinates, so chords, should be, and then we'll just list them to make sure we do get the mark for this exam. We'll put -1, -1, -2, -2, -3, -3, -4, -4, and then finally we'll put -5, -5. And that is, that's definitely enough for the 2 marks in the exam. So for question 15, we are told that a company uses this formula to work out the cost of a taxi ride, where A is the cost. So the cost of a taxi ride is equal to 4 plus 1.8 m plus b, where m is the number of miles travelled, 4 is a fixed charge, and b is the charge for an online booking. We are then told that Claire books a taxi online, so it's online, and she travels 8 miles. She pays £20 altogether, and we need to work out the charge for an online booking. Okay, so we need to work out B. So what we can do is say the total price, which is 20, which is A in the equation. So 20 is equal to 4 plus 1.8 times by the number of miles that she's gone, which is 8 miles. So times by 8. And then we've got plus B, where we need to solve this equation for B. So the first thing we can do is take 4 away from both sides, from this part of the equation. So we are then left with 16 is equal to 1.8 times by 8, then plus B. We'll then work out this bracket here. So 1.8 times by 8 is equal to 14.4. So we've then got 16 is equal to 14.4 plus B. And then we take away 14.4 from both sides to be left with 1.6 is equal to B, so therefore B is equal to £1.60. So for part B of question 15, we are told that a different company has a fixed charge of £3 and they charge £1.90 per mile, and they've got no charge for online booking. Okay, so we need to write a formula for the cost in C pounds of a taxi ride with this company. So they've got a fixed charge of £3, so we can say that C, which is the cost for the taxi ride, is equal to 3, the £3 fixed charge, plus 1.9 from here per mile, so we can say 1.9 M. And there's no booking charge, so this is actually the final answer. Okay, so question 16, we need to say what does A and then this weird N kind of symbol represent in the probability of A, weird symbol B. Now this weird symbol, all it means is intersect. So what it means is what is the probability that some event happens for both A and B, so A and B combined. So if we look at the answers that we've got, A or B or both, nope. A but not B, nope. Not A and not B, no. And then A and B, it is this one because it is the probability of A and B combined, or A intersect B. So the answer is A and B. Question 17, we are told a circle has got circumference C and diameter D. And we're given this formula down here, C equals KD. And we need to say what value does the constant K represent. So this formula here is clearly defining circumference C, and we know that our formula for circumference is C is equal to pi times the diameter D. So we've got D on the right hand side here, and we don't have pi, so therefore K must equal pi from the actual formula. So we can say that the constant K represents pi, and then I'd put in brackets something like 3.14 and then dot 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 dot. Just that the examiner knows exactly what you understand pi to be. Question 18. We are told there are 240 cows on a farm, and for part A, we are given some more information saying that on the farm the number of bulls to the ratio of number of cows is 1 to 30, and we need to work out how many bulls there are on the farm. So the key thing is the ratio is 1 to 30 and we've got 240 cows. So what we can do is we can divide 240, the number of cows, by the ratio of cows to bulls, so by 30. And when we do that, we have 240 divided by 30, and this is equal to 8. So we can see from doing this calculation, if we've got 240 cows, we must have 8 bulls. So the answer is 8. Right, so question 18b, we have to assume the following, that the 240 cows on the farm produce milk for 10 months each year. So I'm just going to highlight the key pieces of information here. 240 cows, 10 months each year. And each cow produces an average of 25 litres of milk per day, so 25 per day. And what we've got to do is estimate the number, the total milk production in litres of the 240 cows in 1 year, so 1 year. Right, so the first thing to do is to work out how many litres all the cows produce in 1 day. So as we've got 240 cows and they produce 25 litres of milk per day on average for each cow, what we can do is 240, the number of cows, multiplied by the amount of milk they produce each day on average by 25. Just grab my calculator. So when we do that, we are left with 6,000. So this is 6,000, and I'll just put some notes on the side here. Litres per day. And then in a year, there are of course 365 days. So we then multiply our 6,000 by 365. When we do this, we obtain 2,190,000 litres. So again, I'll put a little note, whole year. But then we're told that the cows produce milk for 10 months each year. So what we can then do with this number is we can divide it by 12 to find the amount for 1 month. So we do 2,190,000 divided by 12, and this is equal to 182,500. So this is litres per month, so I'll just put per month. And then for 10 months, we just multiply this value by 10, so 182,500 multiplied by 10, and when we do that, we get 1,825,000. And again, a little note, this is 10 months. So do we have to round it to a certain significant figures? No. So we just put this answer we've got here as our final answer because it doesn't ask for, say, 3 significant figures and so on. So we just write our final answer as 1,825,000 litres of milk in every year. Question 19, we are given a right angle triangle as shown in this diagram, and we need to show that x is equal to 12. So as x is the length of the hypotenuse, I'll just call it h. This is our unknown length. What we need to do to work out the hypotenuse length is use Pythagoras' theorem, which states that c squared, I should actually call that c, even though it is also called the hypotenuse, it's called the side c. So c squared is equal to a squared plus b squared, where the other two sides are a and b, respectively. So all we have to do is substitute our numbers or values for a and b into our equation and then solve for c. So what we do is we say c squared is now equal to a squared, which is 7.2 squared, plus 9.6 squared. And then what we can say is c is therefore equal to 7.2 squared plus 9.6 squared, and then the square root of that entire value. And then when we work out what c is, I'll just do this now on my calculator. So we've got the square root of 7.2 squared, and then we've got plus 9.6 squared. So this comes out as 12, but remember it's plus or minus 12, as the square root of any whole number, not just any whole number, any positive number will always give us a plus or minus answer. But as this is a question with a real value, as in we're talking about a length here, we cannot have a negative length. So our final answer is of course just positive 12, so 12 centimetres. Question 20 is worth 4 marks, so it's quite a big question. And what we have to do is work out the values of a and b in the identity, which is shown here. So the first thing that we're going to do is expand this bracket and this bracket to see what we get. So the 5 times 7x gives us 35x. Then we've got 5 times 8, which is plus 40. We've then got plus 3 times 2x, which is 6x, plus 3 times b, which is 3b. We're then going to collect like terms, so 35x plus 6x leaves us with 41x. So we can then say this is equal to 41x, and then we've got plus 40, and then plus 3b. And that is we can't simplify that any further. So now what we're going to do is equate this, 41x plus 40 plus 3b, to the identity in the question up here, which is ax plus 13. What we can then do is compare the two sides. So on the right hand side we've got ax, and the only term on the left hand side concerning x is 41x. So what we can therefore say is a is equal to 41. What we've then got is 13 must be equal to the remaining parts. So 13 is equal to 40 plus 3b. So we'll do another line just showing that. So we've got 40 plus 3b is, we can say equal to actually, is equal to 13. So what we then do is take 40 away from both sides to left with 3b is now equal to negative 27. So b is equal to negative 9, and then we'll just write these as our final answers at the bottom. So a is equal to 41, and b is equal to -9. For question 21, we are given the first 4 terms of a linear sequence, and we need to circle the expression for the nth term. So this is term number 1, this is number 2, number 3 and number 4. So an easy way to do this is to simply sub in the first term value, which is 1, into each expression and see if we actually get 7 as the answer. So subbing 1 into the first one, we do get 7, as 1 plus 6 is equal to 7. The next expression we've got 4n plus 3. 4 times 1 is 4 plus 3 is 7, that works. The next expression 7n plus 4. 7 times 1 plus 4 gives us 11, so this one doesn't work. And the final one, n plus 4, which is 1 plus 4 in our case, that gives us 5, so that one doesn't work. We'll then move on to the second term, 11 being the second term. So we'll do the same thing again, but only for these 2 expressions now. So what we've got is n, which is 2 plus 6 equals 8, so it's not this one. And just for confirmation, we'll apply this one. So 2 times 4 plus 3 does give us 11, so this is the correct answer. So the expression for the nth term is 4n plus 3. Okay, so question 22, we are given some information about 20 trains leaving a station. In the table, we are given the number of minutes late the trains are, between certain parameters, as seen here, and the number of trains that fitted into each category. So for part A, we need to work out an estimate of the mean number of minutes late that a train was. So what we need to do for this is work out the total number of trains, which they've already given us in the question. So we can just write down total number of trains, and that is equal to 20. So to then find an estimate of the mean number of minutes late, as we don't have specific values for the number of minutes late each train was, we need to take an estimate, and they've given us a clue about how to do this in the table by saying midpoint. So we need to find the midpoint of each of these values here. So the midpoint between 0 and 5 is 2.5, midpoint of 5 and 10 is 7.5, midpoint 10 and 15 is 12.5, and then there isn't actually a midpoint for the final one because it's only greater than 15 minutes, greater than or equal to 15 minutes, sorry. And besides, there's 0 trains in this category, so we can almost discount this column, to be honest. What we then need to do is, with our midpoint, which is an estimate about how late each train was for this category, we need to multiply our estimate for minutes late by the number of trains that fell into this category. So the total number of minutes late combined for all 12 trains will be equal to 2.5, the midpoint, multiplied by 12. For the next column, the midpoint 7.5 multiplied by 7, and the final column 12.5, the midpoint multiplied by 1. So when we work all of these values out, what we get for the top one, just grab my calculator, 12.5 times 12, not 12.5, 2.5 times by 12 is equal to 30. Let's not rub that out, I'll use a different colour as well. So that is equal to 30. 7.5 multiplied by 7 is equal to 52.5. And then 12.5 times 1 is of course just 12.5. So what we then need to do is add all these values together to find the total estimated number of minutes late all the trains were combined. So 30 plus 52.5 plus 12.5 is equal to 95 minutes late, and I'll just give a quick label, total estimated minutes late. And then what we need to do is take the total estimated minutes late, which is 95, and divide it by the total number of trains that were in the data set, so 20. And when we do 95 divided by 20, we are left with 4.75. And it doesn't actually say what we should round our answer to. So what we can round it to is, in this question I'd go for 1 decimal place, so I'd round up the 5 to make this an 8. So I'd say each train on average was 4.8 minutes late, and I'd just put 2 SF here. Okay, so just for a bit of added clarity, in the final answer I chose 2 significant figures. You can also leave it as 4.75, I'm just looking at the mark scheme now, and you can also round up to 5 as well, so you can have any of the following answers: 4.75, 4.8 or 5, and they're all acceptable for the full marks. For question 22, part B, we are told that the station manager looks at the information in more detail, and he creates this new table here, which basically just gives more accurate number of minutes late for each train, and he uses this new data to work out an estimate of the mean for the number of minutes late for each train on average, and we need to suggest if his estimate is going to be higher than part A, the same, lower, or not possible to tell. So if we just look at this new table, the midpoint for all of these ranges here is going to be 1, 3, 5, 7, 9 and 11. So if we look at our old table, we can see that we multiplied 12 trains by 2.5. In the new table, we're multiplying 12 not by 2.5 but by 1. So this column here suggests the new data is going to be lower. We've then got nothing for this column here, row, sorry. For the next row, we've got 5 trains, not 5 trains, we've got 7 trains with an estimated number of minutes late at 5. So we're doing 5 times 7 there. In this one, we are doing 7 times 7.5. So again, in this table, this is a higher value than what we do in this table here. So again, this suggests it will be lower. Again, nothing in this row and nothing in this row, as there are no trains with that number of minutes late. And for the final row, we've got 1 train that was 11 minutes late for taking the estimate. So we've got 1 times 11, whereas in our previous table, we've got 1 times 12.5. So again, this is a higher value. So this is a lower value here, so we can say this will give a lower estimate again. And as there's no contradictions, each one says lower in our 3 cases here, we can therefore say that the new table is going to give a lower answer than part A, so lower. For question 23, this is quite an unusual question. It's linking geometry to area of circles and so on. So what it's asking us is to work out the shaded area, which is of course this area here. And we are told that the rectangle contains 2 identical quarter circles. Okay, so these 2 circles, I'll call them 1 and 2, are both identical. Okay, so, and the important thing to note as well is these are quarter circles. So if we imagine what the whole circle would look like, just quickly doing that, we'd have something like this, okay? And from this we can clearly see that this length here is going to be the radius of the circle, as is this length here. These are both the radius of the circle, as they're of course half of the diameter. So if this length here is the radius, as is this length here, we can see that on the vertical length, this entire length all the way down here is going to be 2 lots of the radius. So what we can then say is 12, which is the length of the entire vertical side of the rectangle, is equal to 2r. So 12 is equal to 2r, and therefore 6 is equal to r. What we can then do is work out the area of the entire circle by using the formula for the area of a circle, which is pi r squared. So we say area of circle equals pi times the radius squared. Therefore pi times our radius, which is 6 squared, is equal to 36 pi. Now that is the area of the entire circle, and we've only got a quarter of the circle. So what we can then say is 1/4 area of circle is equal to 36 pi multiplied by 1/4, which is equal to 9 pi. And as we've got two circles, 1 and 2 as labelled here, we can then do our 9 pi multiplied by 2. So we can then say area of both quarter circles equals 9 pi times by 2, which is equal to 18 pi. Okay, and then what we need to do to find our shaded area here is take away our 18 pi, which is this area here and this area here. We need to take that away from the entire area of this rectangle. So the entire area of the rectangle is equal to 12 length times width. So 12 multiplied by 6, which is our radius. So we can then say, I'll just change colour, area of rectangle is equal to 12 times by 6, which is equal to 72. And we can therefore say that the shaded area is equal to, not you Siri, the shaded area is equal to, I'll just write this down, shaded area is equal to our 72, which again is the area of the entire rectangle. Take away the area of our two quarter circles here and here, which was equal to 18 pi from this part that we worked out. So 72 take away 18 pi, and they don't say to give this as a decimal answer, so I just leave the answer as that, to be honest, which is the exact number. 72 take away 18 pi. Question 24 is again a bit of a weird question, but if we take it slowly we can get to the final answer confidently. So the diagram shows the position of a tap when turned off and fully on. So off and fully on is 180 degrees. When fully on, the water flows out of the tap at 14 litres per minute. So again, I'll highlight the key information as I go along. The rate at which water flows out is in direct proportion, that's important, to the angle of the turn. Okay, and we are then told the tap is turned to 135 degrees, okay, as shown here. And the water flows into a tank with a capacity of 79.8 litres. So we then need to work out, will it take less than 7.5 minutes to fill the tank? So the first thing to do, as the amount of water that flows through the tap is in direct proportion to the angle of the turn, is to work out the rate of water flow in 135 degrees. So at 180 degrees, the rate of water flow is 14 litres per minute. So for 1 degree, what we can do is, we can just say for 1 degree on, or we should say turn really, for 1 degree turn, we have 14 litres divided by 180, which is equal to, just grab a calculator, that is equal to 0.07 recurring, and this is litres, I think it's per minute, yeah, per minute. So therefore, at 135 degrees, and the tap is on 135 degrees here, the rate of water is 0.07 recurring multiplied by 135, which is equal to 10.5. So we then get 10.5 litres and then per minute. So we now need to work out how long will it take to fill the tank at a rate of 10.5 litres per minute, and the tank has a capacity of 79.8 litres. So what we can do is say 79.8 litres divided by our rate of flow, which is 10.5. This gives us 79.8 divided by 10.5. That is equal to 7.6. So it therefore takes 7.6 minutes to fill the tank, and 7.6 is greater than the 7.5 minutes. So what we can say is therefore no, it will take 7.6 minutes to fill the tank. Question 25, we are given an equilateral triangle as shown here, and we need to work out, is the perimeter of the triangle greater than 1 meter? Okay, so the important thing to note for an equilateral triangle is, of course, all these sides are the same length. So I'll just write that down. So in equilateral, of course you'd have to write the full word in the actual exam. In equilateral triangle, all sides are the same length. That's what I'll write down straight away, and you'll probably get a mark just for saying that. So what we can then do is we need to find the perimeter. So the first step is to expand this bracket and then add these other sides together to find the perimeter. So we can do perimeter P is equal to 6x minus 10 for this side here, and then we've got plus 4x plus 5, and then we've got plus 10, and then x minus 4. We'll then expand that bracket to be left with 6x minus 10 plus 4x plus 5 plus 10 times x is 10x. Then we've got 10 times minus 4, so take away 40. We'll then collect like terms to get the final answer for our perimeter. So we've got 6x plus 4x plus 10x, which is 20x. And then we've got minus 10 plus 5 and minus 40. So that is equal to minus 45. So that is our perimeter, 20x minus 45. What we can then do to work out the value of x is we can equate any of these two sides together, and they will of course be equal as it's an equilateral triangle and all the sides are the same. So we'll just pick these two sides so that we don't have to expand that bracket again. So we can then say that, let's change colour, we can then say that 6x take away 10 is equal to 4x plus 5. So 6x take away 10 is equal to 4x plus 5. We can then plus 10 to both sides to get 6x is equal to 4x plus 15. And then take 4x away from both sides to get 2x is equal to 15. So therefore x is equal to 7.5. We can then sub our value of x, 7.5, into our expression for the perimeter. So we can therefore say, therefore P is equal to 20 multiplied by 7.5. And then we've got take away 45. So P is equal to, let's put this into our calculator. So 20 times 7.5 and then take away 45. That leaves us with 105, and it is centimetres. And the question asked us, is the perimeter of the triangle greater than 1 metre? So we can therefore say, therefore, yes, the perimeter P is equal to 1.05 metres. Question 26, we are given an approximation for the value of pi, as seen in this expression here, and we then need to use our calculator to show that this approximation is within 0.1 of 3.14. So basically we need to work out what this expression gives us and then make sure that it's within 0.1 of 3.14. So this is simply a case of typing this expression into your calculator and making sure you do it carefully and correctly. So the way I'll do it is I'll put 4 multiplied by open brackets, then inside the brackets 1, take away 22, over 57 plus 22 over 85, and then take away 22 over 105 plus 22 over 117, and then take away 22 over 242. Close brackets, and when we do that, we obtain we get I'll just do an arrow here, so I'll say this is equal to 3.04183, and then I'll just put ... Okay, so what I can then do is say 3.14 from this part of the question here, 3.14 take away our 3.04183 ... is equal to, so we just put 3.14 take away answer in our calculator, and this is equal to 0.098, and then I'll just put 16, so on. So we can therefore say the approximation is within 0.1. Question 27 is quite an easy one to end with, so all we have to do is work out 9.12 times 10 to the 10 divided by 3.2 times 10 to the 4 and give our answer in standard form. So all we have to do basically is put this into our calculator, so fraction button, and then 9.12 times 10 to the 10 divided by 3.2 times 10 to the 4, and when we do this, I'll just do an arrow, but in the exam you should rewrite this expression. I'll just say this is equal to 285, and then we've got 4 zeros that follow on. So the way that we work out the standard form answer is we pretend that this is a decimal point here, and we could have 0 if we really wanted to, and then we've got to count how many places we need to move it until it gets to the second position, so after the first number. So we move it 1, it's not going to let me do it, let me try again. So 1, 2, 3, 4, 5, 6 places, so we can therefore say this is equal to 2.85 times 10, and we've moved it, let me just count again, moved it 1, 2, 3, 4, 5, 6 places, so it's to the power of 6.